Hello everyone, I'm Suhas. I'm a third year PhD student from UNC Charlotte. I work under Dr. Robert Cox, Dr. Ahmed Arafa, and Dr. Kyle Badbury from Duke University. So research team has been working with like two large portfolios of roughly like 4,000 buildings from Bank of America and roughly like 5,200 buildings from Wells Fargo. So most of these buildings were under 10,000 square foot, which is considered as small for industry standards. And there was a recent literature survey that Kim and Kurtimopoulos did on 200 studies for different automated fault detection diagnostic method. And out of those 197 studies, only 31 of those studies focused on small buildings, and they particularly focused on air conditioners and heat pumps. So most of the recent studies focused on the detailed performance of the HVAC systems that require specialized sensing, and our field studies show that these issues that happen with the performance of the systems don't necessarily dominate, and they don't necessarily answer on the most commonly asked question as to why one building is performing worse than the other. Here you can see that the most current systems take into consideration the values for zone temperature, set point schedules, and discharge temperature, and the change detect as they occur. But based on the historic information and the available data approaches that we have, they do not necessarily answer why one particular building seems to be working out of the ordinary. They do not answer a common portfolio on a question as to why one building is performing worse than the other. So here you can see that there are four buildings which look the same. They're in the same climatic conditions, the same working schedules, but their energy use intensity is different. So, see, the idea of just looking into the equipment health and HVAC sensor data itself is sometimes not sufficient. Often, the issues that happen with the buildings are overlooked. So, some of the overlooked issues are like heating set point problems, like leaky buildings, as in the conditioning in the building is not staying in. Either too much air is coming out, or the building itself has envelope issues where outside air is coming in, or the conditioning inside is going out quickly, or the faulty thermostat locations, or numerous data quality issues that come with like having buildings with sensor data. So here you can see that on the simple thermostat issue that happens, someone decided to like change the thermostat heating set point values from 65 to 70, and also change the way the schedule of the heating set point changes. So here you can see in the bar graph that the heating runtime for an older schedule was much lower compared to like the newer schedule, and that resulted in like an extraordinary amount of heating runtime for the same time of the day for the entire month. So this could have been easily avoided if they had prior knowledge of what the impact of changing set point schedules would be. So here you can see one more issue, that the brown line is the room temperature. So generally we expect the room temperature to perform once it's inside the band between heating and the cooling set points. We generally expect it to like go down slowly, but here you can see that there's a rapid rise in room temperature. So we in our field study we found out that this was right next to like a heating source. These are common issues where the thermostat is placed next to like a coffee machine or a printing machine, which results in like unnecessary like spike in the room temperature and like unnecessary conditioning, and these issues drive energy consumption. So we came up with a two-step approach to determine the relationship between HVAC energy and total energy. So first we trained a model relating HVAC energy with an overall energy use intensity to classify buildings as good, bad, or moderate performers. So we started off with like a very simplest model and progressed into like higher complexity models with an emphasis more on interpreting the results rather than predictability. So once we classify this system as like a high energy consumer in terms of heating energy or cooling energy, we can figure out we can figure out a way to establish a relationship between already known parameters that are driving energy use with respect to heating energy. So our work would provide facility managers with a tailored walkthrough on how to like set their set points right and looking into other issues. And also like there would be an analytics engine for the portfolio which can be derived from the work that we did, and a description of the thermostat analysis approach. So among all the Wells Fargo buildings that we surveyed, annual average energy consumption per site is roughly 80,000 kilowatt hour. So achieving just a 1% reduction in each of these 6,000 buildings would represent the removal of about 380 residential homes from the grid. This savings provide financial benefits and promote welfare of both the living world and also saves money for the corporates.